take CK and BK, plug it back into this equation above. You can then find the Fourier series coefficient for AK. Okay, so hence you get AK that is equal to, right, if K is 0 plus minus 5 plus minus 10, then you have 1 plus 3 over 5, which is 8 over 5, right, for K not equal to, K equal to 0 plus minus 5 plus minus 10 and so on, okay? Now, if you have, K not equal to 0 plus minus 5 and so on, then you have CK0 plus BK, which is this. So this is essentially BK, which is 1 over 5 sine 3 pi K over 5 over sine pi K over 5. Okay, where K not equal to 0 plus minus 5 plus minus 10, so on. Okay. So do we have any questions here?只有
老师，那个 BK 那个 sin 的那个方程式是怎么看出来的啊？
这个就是从 3.12 的结果得来的。
那你直接用它的结果是吗？
对。
好的，谢谢。
所以在这里我们就是套用 n1 等于1，然后大 N 等于5的情况。到下面这个式子来。对，所以大 N1 如果等于1的话，这里就是3/2嘛。那2 cancel out， 这里就是3pi k over 5。大 N 是5。OK， 那分母就是 sin pi k over 5这样子。可以吗？
好，谢谢，了解。
对，这边还有没有其他问题？
老师，那个 for n 等于，那是 n1 等于1吗？
对 ，n1， 觉得有点歪，是吗 ？n1。好，
教授，
是，
想要请问一下 CK 是怎么求的
？CK 就是用我们的 Fourier series 的这个式子求的。就是这个式子求的。OK， 那当你在看k 等于0这一项的时候，就是 C0的话 ，k 等于0这一项，这个 exponential 就只是一个 constant 1嘛，所以 C0这一项其实就是去平均我的讯号 over one period。可以吗？
那就是为什么它是就是在正负10的时候才会有值这样？
对，那就是说，当然你也可以去把它一个一个求出来 ，OK。OK， 就是说你当然也是可以把它一个一个求出来 ，OK， 但是因为你这个 C0项就已经等于1了 ，OK， 所以你这个1就已经是 reconstruct 原本的 x2n 这个讯号了，它就是全部都是1 ，OK， 所以其他的这个 ck 其实一定都是0。那如果你要的话，你也是可以把它确切的算出来哦。就比如说的 ck 如果按照刚才的公式的话，就是这个 summation xn e to the minus j k 2 pi over capital N over one period, which you can take as summation from 0 to 4. Right. 那因为 xn 都是1嘛，这里的 这里是 x2n。OK， 所以 x2n 都是1，所以其实这就是 summation of the complex exponential. OK， 那当你 sum over one period of a complex exponential of 这个 periodic 的 complex exponential， 它正的就像是一个 sinusoid 一样，它的正的地方就跟负的地方 cancel 掉，所以你 sum over one period of a sinusoid 就会等于0。
哦，了解，谢谢教授，谢谢教授。
Okay. 所以我想更精确的话，这里大 N 是5，可以直接带5进去。对不起，这里应该是 sum 到4而已。OK， 就是说你们可以就是说确切就是每一个 ck 都把它算出来，但事实上在这里是没有必要的，因为你光算出 C0 C0 等于1就已经是完整的 reconstruct 这个x2n 这个讯号了。OK， 所以其他的 coefficient 一定都是0。
教授，
是。
我想请问为什么那个 n1 是1
？n1 是1，就是你手上有那个 3.12 那个 example 吗？
有。
所以 3.12 那个 example， 它 n1 就是设定是从 minus n1 到 n1 这样子。那我们在这里 n1 就是1。
哦 ，OK， 谢谢教授。
好。Okay, so let's maybe move on to the next.
老师。
对，好 ，OK。
抱歉，那个可以讲一下蓝色部分吗？蓝色部分可以再讲一次吗？
就说确切哪一个地方？
就是为什么这样会是0？
你说最后这个为什么是0吗？
对。
因为当然你可以就把它展开，你可以把它展开就自己算一次，你就会看到它是等于0了。但是就说如果你从这个图解来，就说从intuitive 的图解来看的话，因为这个 complex exponential 就是一个 sinusoid， right？ 它的 real part 跟 imaginary part 都是一个 sinusoid。那你这个是 sum over one period of a sinusoid， 所以正的地方就会跟负的地方加起来 cancel 掉。对，但是你就是确切把它展开算一次，也是可以的。对。
好，谢谢老师。
好。 Okay. All right, so in this example, we gave several conditions, and you're asked to find what this signal x of n is, right? So we had a similar example in the continuous time case. Right, so first of all, here we have the first condition says that xn is periodic with period capital N. Okay, so we know by the first condition that the signal has period capital N equal to 6. Now, by this second condition, we know that the summation of xn from 0 to 5, which is a summation over one period, is equal to 2, right? So, maybe from this previous example, you already see that, summation over one period helped you compute the coefficient for k equal to 0, right? So by 2, right, we can compute the coefficient for k equal to 0, which is 1 over the period times the summation over one period, okay? And since this summation is 2, this is 1 over 3. Okay. Now, again, by 3, we know that the summation of n equal to 2, from 2 up to 7, of minus 1 to the power n x of n is equal to 1. Okay. Now notice that this is also a summation over one period, even though the starting point and the ending point is different from the above, but it's taking a summation over capital N consecutive values. Okay. Now, furthermore, you can observe that minus 1 to the power n can also be represented in terms of a complex exponential. Right. So in particular, by 3, notice that since minus 1n, you can write as e to the minus j pi n. Okay. E to the minus j pi is minus 1. Okay. So e to the minus j pi n is minus 1 to the power n. And then you can further write this as e to the minus j 2 pi over 6, where 6 is the period, times 3n. Okay. So if you look at this, you can see that this is actually the complex exponential corresponding to the coefficient with index k. Okay. So this means that, if you represent minus 1 to the power n as this, what this summation gives you is something that helps you compute the coefficient A3. Okay. So A3, which is 1 over 6 summation over one period, let's take 2 to 7, xn e to the minus j 2 pi over 6 3n. Okay. Now this is equal to 1 over 6 summation n from 2 to 7 minus 1 to the power n xn. Okay. Now we know by 3 that this summation here is 1, so this coefficient is just 1 over 6. Okay. So now we have the coefficient values for A0 and A3, right? Now the fourth condition tells us that xn has the minimum power per period among the set of signals satisfying the previous 3 conditions. Okay. So we know that for a signal that is periodic with period n equal to 6, we can write it in terms of its Fourier series representation, where xn should be equal to summation a k e to the j k 2 pi over 6 times n from, let's say, 0 up to 5. Okay? Now, A0 we know is 1 over 3. A3 we know is 1 over 6. So, any signal that satisfies the first 3 conditions should be able to be be represented by in this form with A0 and A3 given by 1 over 3 and 1 over 6 respectively. So the only values that are not specified are A1, A2, A4, and A5. Okay. But condition 4 tells us that xn has the minimum power per period among all signals that satisfy these 3 conditions. Now, by Parseval's theorem, right, when you see minimum power per period, right, you intuitively think of Parseval's theorem, okay, Parseval's relation, right? Because Parseval's relation tells us that Parseval's relation tells us that the average power of the signal over one period, right, which is 1 over 6. Okay, let's denote this by P. Right, the average power over one period is 1 over 6 and summed over one period xn squared, right, should be equal to the summation of ak squared, k from 0 to 5. Okay. So if you're saying that xn is the signal with the minimum power satisfying these conditions here, then this by Parseval's theorem we know that A1, A2, A4, and A5 should all be 0, right? Otherwise, you would be increasing the average power. Okay. So by 4, we know that AK should be equal to 0 for K equal to 1, 2, 4, 5. Okay. So then, by plugging all these values back into this Fourier series representation, we find that xn is 1 over 3. Okay, or let me say A0 plus A3 e to the j 2 pi over 6 3n. Okay, which is 1 over 3 plus 1 over 6 to the up 1 over 6 minus 1 to the power n. Okay. Okay. So you can also plot this out if you like. So here you have xn. Okay. So when n is even, right? When n is even, minus 1 to the power n is 1. So we have 1/3 plus 1/6, which is 1/2. Okay. So let's say this is 1/2. You get 1/2 here, 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 and so on. Now for n that is odd, right, you have 1/3 minus 1/6, which gives you 1/6. So you have points here, here, here. And so on. Okay.
老师，那
请说。
个问一下第4点嘛，就是再解释是第4点。为什么？
OK， 所以Parseval's theorem、Parseval's relation 告诉我们说，这个讯号的 average power 就会等于它的这个 Fourier series coefficient 的这个平方，就是绝对值平方的和。OK。
对。
那我前面3个 condition 让我知道的是说，这个 A0 会是1/3，然后 A3 会是1/6，所以 A0 跟 A3 是不能动的。Okay. 那如果说我希望这个讯号是有 minimum 是符合这条件的这个拥有 minimum power 的这个讯号的话，那么我就必须要让其他的 coefficient 等于0。
所以第4点的意思是说，就是在所有符合前面3点的情况下，还有最少 power 的那一个。
对对。
好。
OK， 谢谢。
谢谢老师。